Okay, now we're going to write names and formulas for different kinds of compounds. Okay, so these we first want to determine if it's ionic, covalent, or polyatomic. So we're either going to be using the formula to determine if it's ionic, covalent, or polyatomic, or down here we're going to have the chemical name. All right, I've got this great little flow chart for you, and it's loaded in Canvas, but you can get this from me. How to use this chart. Okay, so what's it made of? Is it a metal and a nonmetal? Then it's going to be ionic. 2 nonmetals, covalent. Is it 3 or more elements? Then it's going to be polyatomic. Okay? And if we're looking at the name, our clues on those is they're going to end in ATE or ITE, and here we see those exceptions. Okay, so I want you to fill out the first column here, ionic, covalent, or polyatomic, because if you'll fill out this first column first, that will help you with the naming and the formula. Okay, for example, here, I'm going to look these elements up, and I'm going to find out if I have a metal plus a nonmetal, 2 nonmetals, or 3 or more elements. Okay, so here I've got a metal plus a nonmetal. So I know that's ionic, right? If it is ionic, remember, we're going to use the IDE ending. No Greek prefixes, okay? Our Greek prefixes are here. The only time we use those is for covalent compounds. So no Greek prefixes. So I want to write a name for that. So the metal's name stays as is. The nonmetal gets the IDE ending, okay? This is not dilithium sulfide. No prefixes. Again, it reminds me every time. If it is one of those transition elements or metals, make sure you're using the Roman numerals. How do you know? Because you're going to go back to your ion chart and you're going to look that up. Sodium doesn't have any Roman numerals, so I don't need one. But if I have iron, iron has Roman numerals. Okay, so I'm going to name this. What's its name? Sodium with chlorine, which becomes chloride. So the name of this is sodium chloride. Ran out of room there, but that's okay. All right, so use that chart and see if you can figure those out. Ionic, covalent, or polyatomic. Okay, what if we have the name though? Okay, let's look at one right here. So I've got sulfur. All right, so I find sulfur here. He is a nonmetal, so I've got a nonmetal. And then oxide, remember, is oxygen. So that's another nonmetal. So I know that is covalent, right? And then I want to write the formula for that covalent compound, okay? How many sulfur do I have? Well, there's no prefix, so there's 1 sulfur. And this will remind you, too, on here, remember, all right, we're not going to use any charges, no charges. Instead, we're using Greek prefixes, okay? So here, how many oxygen? 3, so sulfur trioxide. All right, what if we have something like this? Let's look at this one. We've got magnesium. Magnesium is a metal because where is magnesium? He's right here. He's right here. He's a +2. Okay, we're going to need that also. So I'm going to put Mg +2. Okay, acetate. All right, there's that ATE ending. What does that tell you? That ATE ending is my clue that it's a polyatomic ion. And you have an ion chart, but this also tells you right here. There's acetate right here. It even gives its charge. It says that is its formula, and we're going to need that. C2H3O2, and that whole thing's a -1. So we've got 3 or more elements, so we know that is poly, meaning many, atomic. All right, so what do we have to do? If we have a covalent or not covalent, a polyatomic or an ionic compound, what do we need to do? We need to swap and drop. So that 2 comes back behind the acetate, The 1 goes there, so I've got 1 magnesium and how many acetate? 2. Oops, I'm out of the screen there. So can you see that? Magnesium acetate. All right, so on polyatomic and ionic, I need to swap and drop. All right, again, follow along on this chart. Let me know if you need help.